Welcome everyone, welcome to this video. This is the first video I'm making with vectors, and I'm going to focus on the areas here, part B. But we start with the whole question here. The question says that refer to a fixed point O, the position vectors of point P and Q are given over here, and you have a vector R that divides PQ internally in a ratio of 2 to 1. There's no diagram here, so I made a sketch of this and I put their order points on the sketch. So my first question here is to find the position vector of R. Position vector of R is the vector OR. I can draw the line here so you can see the vector OR from O to R over here. So if I'm looking for this vector here, you can see that the vector OR, we are answering part A, vector O to R is a movement. The question of vectors, like how do you move from O to R? I move from O to P and then plus P to R. So I have OP plus PR, but PR is just 2 over 3 of PQ because R divides PQ. But you have OP. What is OP? What the vector of OP? So OP is 10I minus 3J. You add this one to 2 over 3 of PQ. I'll find PQ over here. PQ is supposed to be OQ minus OP from the diagram. If I'm looking for P to Q, I'm going to move in the opposite the side of P. Then I'm moving the positive side over here. So you have OQ plus minus OP. That means PQ is a vector. What is OQ? OQ is 4I plus 6J minus OP is equal to 10I minus 3J. That means PQ is a vector which is 4I minus this. So what we have here, we have minus 6I and 6J is going to be plus 9 plus 9J. All right, that means what you have here, we come back here for OR. So you have 2 over 3 of minus 6I plus 9J. So what we have here, we have 10I minus 3J plus, when you multiply here, we have here minus, we have minus, when you up 2 over 3 times 6, what's 2 over 3 times 6? We have minus 4I, and then this one here, 2 over 3 minus this, we have plus 6J. So your final answer of OR is a vector 10 minus this one here, which is equal to 6I, and minus 3 plus 6J, which is going to be plus 3J. This is a vector of OR, which is a position vector of R. So the position vector is 6I plus 3J. Now let us move to part 2. Now let us move to part B. From part B, we start with this statement here. We say that S divides OQ in the ratio of 5 to 4. So we assume point S is over here. This was the point R. And then there's a ratio of 5 to 4. They want us to find the ratio of the areas. So what we say here, how we start here, we let the area of triangle OPQ be X. The area of triangle OPQ be X. But what you see here, this ratio here is going to divide this big triangle into 2 triangles, if you can see over here, into 2 triangles. So we shall have a triangle OPS and the triangle SPQ. Now, if you see this triangle here, these triangles have the same height. This triangle have the same height. If I can try to sketch it over here, they have the same height. If you can try to visualize it over here, they have the same height here. Right? So since they have the same height, the difference in their areas is going to be the difference in the bases, in the base. But when you see the base of this triangle here, the base of this triangle here, and the base of this triangle here, the base of this one here is S to Q, and the base of this one here is O to S. They all share the same baseline or Q, which is divided in this ratio here. That means since the baseline, they share the baseline and the baseline is divided in this two ratio here, it means that even the areas of this triangle here, they are divided in the same ratio. The areas are going to be divided in the same ratio. So the areas of the triangle are also in the same ratio as the ratio of the bases. That means OS here, since OS is going to be 5/9 of the whole line or Q, and then SQ is going to be 4/9 of OQ. This is the ratio. That means even the area of OPS to the OPS is going to be 5/9 of X, the area of the whole thing. And also the area of SPQ is going to be 4/9 the area of X, because the total should give you X to give you the total area of the big triangle. Now, if we change our focus now, and now we focus on only triangle PQ, that means this triangle over here, the triangle PQ, PQS, this triangle here. This triangle here is further divided into two other triangles here. This one over here. And these triangles here, their base is still on the same baseline and they share the same height. That means the ratio was 2:1. It means that the triangle, the area of SPR to the area of SRQ is going to be 2:1, because they share the same height. They have the same height and they share the same baseline, but different length in the given ratio. That means even the triangle here SRQ is going to be 1/3, because the ratio, the total of the ratio is 3, so I have 2 plus 1 is equal to 3. It is the same thing we did over here, because this is the 5 to 4, so I have 5 plus 4, that's why I have 9, and then I have 9, 5/9 and 4/9. That means the triangle SRQ, its area is 1/3 of this triangle which it's coming from, that is SPQ. But we know what is SPQ? SPQ, we know it from over here, it is 4/9 of X. That means triangle SRQ is 4/27 of X. Therefore, that means we have the ratio of OPQ to SRQ is OPQ was X, and this one's going to be 4/27 of X. Therefore, you can see from over here, you can see that lambda is going to be 27/4.